Good morning, all of you. Today's topic is third BSc um, Physics, Semester 5, Paper 6, Modern Physics, first unit, first topic, Bohr's Theory of Hydrogen Atom by V. Nagababu, a lecturer in physics, VSM College. What are the contents including in Bohr's theory of hydrogen atom? First of all, we are discussing the contents of Bohr's theory of hydrogen atom, Thomson's atomic model, drawbacks of Thomson's atomic model, Bohr's atomic model, drawbacks of Bohr's atomic model. Next point, Sommerfield's atom model, and then drawbacks of Sommerfield's atom model, the vector atom model, conclusion and references, whatever it may be. First of all, why Bohr's theory of hydrogen atom was discussing? For the fine structure of hydrogen atom, whenever according to Thomson's atomic model, he assumed in those days all the electrons embedded in positive charge, like watermelon, the seeds embedded in a flesh. Thomson suggested the electrons enter into the constituent of all atoms. Since the atoms as a whole is electrically neutral, the quantity of positive and negative charges in it must be the same. Drawbacks of Thomson's model. He explained the hydrogen can give only single spectral lines. Whenever the atomic model is considered, the electron is revolves around the positively charged nucleus. Whenever the electron jumps from higher energy level to lower energy level, the difference amount of energy of the two orbits is radiated in the form of electromagnetic radiation that should be appeared in atomic spectrum as a line. Hence, the atomic spectrum is known as emission spectrum or line spectrum or atomic spectrum. Here, the drawbacks as far as Thomson spectrum is considered, he explained the hydrogen can give only single spectral lines. He could not explain the fine structure of the hydrogen spectrum. According to Thomson's atomic model, he could not find out where the positive charge is concentrated within the atom. He may assume it spread out the entire region. He may assume it spread out the entire region of the atom, like watermelon, the seeds like electrons, flesh like positive charge. Next slide, Bohr's atomic model. According to Bohr's atomic model, he, he postulated two main postulates. One is an electron revolving around the nucleus in a certain specified orbits, and as long as it revolves in the orbits, the electron will not radiate any energy. These orbits are called stationary orbits. Whenever the electron revolves around the nucleus, the energy does not radiate or does not absorb the energy. Hence, the orbits are called fixed orbits. The fixed orbits are known as stationary orbits. Hence, the electron revolves in a circular orbit in which the angular momentum is quantized and integral multiple of h by 2 pi. Why the angular momentum becomes quantized, becomes nothing but constant? Why? Whenever the electron is revolved in a circular orbit, the radius does not change. Radius means the distance from electron to centrally nucleus does not change, hence the energy does not change, the momentum does not change, therefore the angular momentum is integral multiple of h by 2 phi. From that equation can be written as mvr is equal to nh by 2 pi. Mvr is angular momentum, is integral multiple of h by 2 pi. N is an integral multiple where n is equal to 1, 2, 3, etc. is an integer. Second assumption, when an electron jumps from higher stationary orbit to the lower stationary orbit, the difference amount of the two orbits is radiated in the form of quantum energy or in the form of electromagnetic radiation. Therefore, the formula can be written as higher energy level is represented as En, lower energy level is represented as Em. En minus Em is equal to h nu, where n is greater than m. N is higher energy stationary orbit, m is lower energy stationary orbit. The second equation represents the energy of the spectrum. Radius of electron orbit. Whenever the electron revolves in a circular orbit, the radius can be calculated. R suffix n is equal to n squared h squared epsilon naught pi m e squared. This is third equation where n is equal to 1. We get the radius of Bohr's first orbit approximately 0.53. Here the total energy of the electron in nth orbit is given by En is equal to minus m e to the power of 4 8 epsilon naught square h squared n squared, where n is equal to 1, 2, 3, etc., which gives number of orbits. For example, n is equal to 1, k orbit it is very close to nucleus in an atom. If n is equal to 2, l orbit, n is equal to 3, m orbit, n is equal to 4, n orbit, and so on. Hence, Bohr's theory could successfully explain about the circular orbit of the electron around the nucleus. That is, all the electron orbits are circular. Here, n is known as the principal quantum number which represents the circular orbits. Here it is very clear, different spectral series of hydrogen spectrum. When the different spectral series can be obtained, when n is equal to 1, 2, 3, etc. Orbits, left side and right side, the energy is given in the above formula. Minus m e to the power of 4, 8 epsilon naught square and square h squared. That is Bohr's orbit energy formula. Therefore, when the electron jumps from higher energy level, n is equal to 2, 3, 4, 5, 2, n is equal to 1. The series is called Lyman series. The series is in ultraviolet region. The range of ultraviolet region is 912 angstrom units to 1218 angstrom units. When the electron jumps from n is equal to 3, 4, 5, 6, 7 to m is equal to 2, the series is called Balmer series, which is in the region, visible region. The range of visible region is 3600 to 6600 angstrom units. 1 angstrom unit is equal to 10 to the power of minus 8 centimeter or 10 to the power of minus 10 meter or 10 to the power of minus 9 nanometers. So n equal to 4, 5, 6, 2, m is equal to 3. The series is called Paschen series. Paschen series, which is infrared region. The infrared region can be divided into three types. One is near infrared region, which is very close to visible region, is called near infrared region. Paschen-Bach series is in near infrared region. When n is equal to 5, 6, 7, 2, n equal to 4, the series is called bracket series. It is infrared region. The range of infrared region is almost 7,000 angstrom units to 54,000 angstrom units. Of course, n is equal to 6, 7, 8 to lower energy level m is equal to 5, the series is called Pfund series, which is also in the region of far infrared region. Therefore, this is the different spectral series of hydrogen spectrum by obtained from Bohr's theory of hydrogen atom. Therefore, when n is equal to 1, we can observe the left hand side diagram. The inner circle represents the nucleus. The immediate outer circle is n is equal to 1, that is k orbit, that is called Lyman series. N is equal to 2 represents L orbit, the series is Balmer series, and n is equal to 4 and n is equal to 5, 6 called Paschen series, bracket series, and Pfund series, so on. What are the drawbacks of the Bohr's theory of hydrogen atom? Why the Bohr's theory could fail to explain his theory? These are called Bohr's theory of drawbacks of Bohr's theory of hydrogen atom. One is Bohr's theory was successfully explained about hydrogen spectrum, but it was fails to explain the following facts. One is Bohr's theory could not give the information regarding distribution and arrangement of electrons in an atom. In an atom, how many electrons distributed in different orbits? How many electrons arranged in a manner in different orbitals inside an atom? That could not be explained by Bohr's theory of hydrogen spectrum. And also Bohr's theory fails to explain the intensity of various spectral lines, which is experimentally observed of an element, which could not explain the intensity of these spectral lines. One strong line, there is a faint line is very close, that is fine structure of the hydrogen spectrum, that could not explained by Bohr's theory of hydrogen spectrum. Next, it could not explain various chemical bondings, covalent bond, ionic bond, metallic bond, various chemical bondings between different atoms, that could not explained by the Bohr's theory. And also this theory fails to explain the splitting of spectral lines in magnetic field and electric field, that is Zeeman effect and Stark effect. What is that? Whenever the source of atomic spectrum placed in external magnetic field, each line can be resolved into 2 or 3 component lines, that could not explained by the Bohr's theory. That is one of the main drawback. Whenever the source of atomic spectrum is placed in external electric field, the Bohr's theory could not explain. Each line can be resolved into more than 2 or 3 component lines. Number of component lines in electric field, that could not explained by the Bohr's theory. All these are drawbacks of Bohr's theory of hydrogen spectrum. And then the Sommerfeld relativistic atom model is introduced to explain all the drawbacks overcome from Bohr's theory. What we obtained, the drawbacks of Bohr's theory of hydrogen atom, that should be overcome by introducing Sommerfeld relativistic atom model. What is the Sommerfeld relativistic atom model? To overcome the drawbacks from Bohr's atomic model, Sommerfeld introduced two modifications. What are the two modifications? One is the motion of electron around the nucleus in an atom is elliptical orbit. The motion of electron around the nucleus in an atom is elliptical orbit, hence taking into account the variation of mass with velocity. If the motion of the electron is elliptical, then the distance between, please observe the diagram left hand side, the distance between electron to nucleus is varied. Suppose if the electron is moving very close to nucleus, the radius r becomes changed, if the axis becomes changed. Therefore, if it is very farthest to the nucleus, hence the radius may be increases, the velocity may be decreased, and hence the mass may be increased. Hence, here one thing, the Sommerfeld introducing one most important characteristic. It may be the electron revolves around the nucleus in an atom, may be elliptical orbit, just like all the planets revolves around the sun as its one of its foci in galaxy. He assumed like that. Suppose if the path of the electron around the nucleus may be elliptical, hence with respect to the velocity of the electron, the mass may be changed. If the mass may be changed, the momentum may be changed. If the momentum may be changed, hence the energy may be changed. If the energy may be changes, the each line can be resolved into two or three component lines. The answer should be getting. This is the reason Sommerfeld assumes the path of electron motion around the nucleus may be elliptical. He assumed. Due to elliptical orbiting motion of electron around the nucleus conform to two-dimensional. If it is elliptical orbit, it is a two-dimensional. Why? Because if the x and y axis may be changed with respect to the uh, position of the nucleus in elliptical orbit path. Hence, Sommerfeld introduced two new quantum numbers. One is nr and other is n pi. Nr is radial quantum number and n pi is azimuthal quantum number. What is nr? Why we are called as radial quantum number? R is the distance between nucleus to electron on elliptical orbit path. Therefore, the new quantum number is regarding as the radius is nr. And what about n pi, azimuthal quantum number? If the electron revolves around the nucleus in elliptical orbit, the angle may be changed. Here, the radius vector which makes an angle with the x-axis, if the angle may be changed, hence the angle quantum number is known as azimuthal quantum number, which is represented as n pi. They stand for one periodic system. Elliptical orbit for hydrogen atom, they stand for one periodic system. Look at the diagram. According to these two assumptions, radial quantum number nr and azimuthal quantum number n pi, which regarding the motion of the electron around the nucleus, if it is elliptical orbit, it is confined to two-dimensional motion. It is confined to two-dimensional motion. Therefore, nr plus n pi is equal to n, where n is known as principal quantum number, as we discussed in previous slide. N is principal quantum number. It determines the orbital angular momentum of the electron. Its value vary from 0 to n minus 1. N is principal quantum number. It determines the orbital angular momentum of the electron. How we can determine orbital angular momentum? N is a principal quantum number, but orbital quantum number, how we can determine? It is very clear. Here, if the electron revolves around the nucleus either in circular according to Bohr or in elliptical orbit according to Sommerfeld theory, the projection of motion of electron from nucleus, which is represented by L. L is called orbital quantum number. Orbital quantum number is represented by L. L is equal to n minus 1. N is principal quantum number, is integral value, integer value. N is equal to 1, 2, 3, 4, etc., which refers, principal quantum number refers orbitals, represents orbital. N is equal to 1, k orbit or k shell. N is equal to 2, principal quantum number n is equal to 2, L shell or L orbit. Principal quantum number n is equal to 3, M orbit or M cell, and so on. That means principal quantum number represents the shells or orbitals, shape of orbitals. Here, the orbital quantum number represents the motion of the electron around the nucleus, which is projected that gives angular momentum L or angular quantum number, orbital quantum number L. L is equal to, what is the formula? N minus 1. If n is equal to 1, 2, 3, etc., L equal to 0, 1, 2, 3, etc. What is refers L? L refers subcells of the orbits of electron orbits, subcells. N is equal to 1 is k orbit. Each orbit contains subcells. The subcells can be represented by orbital quantum number n. What is the formula? L is equal to n minus 1. N is equal to 1. 1 minus 1, 0. L is equal to 0. S orbit. K orbit contains one subcell, that is S subcell. If n is equal to 2, 2 minus 1, 1. That means L equal to 0 and 1. Two subcells. N is equal to 2 means L orbit. L orbit contains two suborbits or subcells. L is equal to 0 and L is equal to 1. L is equal to 0, S subcell, and L is equal to 1, P subcell, P orbit. Therefore, it is very clear. N is a principal quantum number. L is a orbital quantum number. The principal quantum number refers the shape and size of the orbit, and orbital quantum number refers the shape and size of the subcell. S means spherical, P means principal, and so on. D means dumbbell, and so on, etc. Next, this orbital quantum number L is useful in finding the possible elliptical orbits. The possible elliptical orbits are such that B by A is equal to 1 plus 1 by N. What is B and what is A? B is a semi-minor axis of the ellipse. A is semi-major axis of the ellipse. Therefore, it is the possible elliptical orbits can be confined is two-dimensional. There is a formula B by A is equal to 1 plus 1 by N. These possible suborbits possess slightly different energies because of the relativistic variation of the electron mass. And then next, n equal to 1, L equal to 0. I am already explained this point. When n is equal to 1, principal quantum number, that refers to k orbit. Then L is equal to formula. What is the formula? N minus 1 means L equal to 0. In this, the energy level, there is only one orbit or subcell for the electron. Also, where A is equal to B, the first orbit is called circular orbit and also Bohr's orbit. The two axes of the ellipse are equal, hence it is circular orbit and also called Bohr's first orbit. Bohr's first orbit is always circular orbit. Remaining all are elliptical orbits according to Sommerfeld theory. Here, one thing we must remember, the Sommerfeld theory completely gives about the drawbacks of the Bohr's theory, but it cannot give the complete evidence of fine structure of the hydrogen spectrum, simply hydrogen atom. The Sommerfeld theory only successfully explain except Bohr's first orbit, remaining all are elliptical orbits. That was successfully explained, but Sommerfeld theory is also fails to explain the fine structure of the hydrogen atom, fine structure of the hydrogen spectrum, and also the distribution and arrangements of the electrons in different orbits and different subcells in an atom. And also it fails to explain the Zeeman effect, Stark effect, and orientation of the electron in different orbits. Orientation means the electron occupies in a subcell is in a direction or in opposite direction. That could not explained by the Sommerfeld theory. These are all the drawbacks could not overcome by the Sommerfeld theory. Of course, The next point, the subcell corresponding to L equal to 0, 1 and 2 are designated as 3s, 3p and 3d respectively. Of course, we need not bother about 3s or 1s or 2s or 3p or 2p. Whatever baby, it is very clear. 3s, 3p, it is nothing but 3 is a multiplicity. Further classes we have to discuss about the multiplicity. Remember this point. Next point, it is common practice to assign letters to L values as given below. When n is equal to 3, then L is equal to 0, 2 and 3. When n is equal to 3, then L is equal to 0, 1, 2, 3 and so on. Here K means n pi. Remember, K means azimuthal quantum number n pi. N is n minus 1, where n is equal to 1, 2, 3, etc. Orbital quantum number L and electron state. Suppose if orbital quantum number n is equal to 3, L equal to 0, 1, 2, 3, or if as n is equal to 4, n is equal to 0, 1, 2, 3, n is equal to 5, L is equal to 0, 1, 2, 3, 4 and so on, etc. Therefore, the corresponding subcells represents the state. How we can represent? Orbital quantum number L is equal to 0, S subcell, L is equal to 1, P subcell, L is equal to 2, D subcell, L is equal to 3, F subcell and so on. Hence, all these calculations after Sommerfeld elliptical orbit relativistic correction, the energy may be obtained and calculated as En is equal to minus mu to the power of 4 z squared 8 epsilon naught square h square n squared. Therefore, from the above equation, they could not observe the change in energy of the hydrogen spectrum. No change. The same energy is obtained. Hence, if the same energy is obtained from Bohr's theory, the Sommerfeld could not explain why each line can be resolved into a group of lines or the number of lines. He could not explain. If he maybe got the change in energy, he could explain. But otherwise, the energy is obtained as same as in the Bohr's theory of hydrogen spectrum. Therefore, he could not explain the fine structure of the hydrogen spectrum. Therefore, one thing we must remember here, left hand side diagram, if n is equal to 3 or 4, then nr and n pi, remember first orbit and nr is equal to 4 and n is equal to 4, that is the Bohr's first orbit is circular. Remaining all orbits are elliptical. Here, one thing we must remember, uh, the radial vector are not equal to not equal to 0. If it is r equal to 0, the electron is moving throughout the axis nucleus twist that of one time period. It is impossible. It can, there is the penetrating erases, but the electron does not penetrating with the nucleus as per the atomic theory is considered. Next, drawbacks. Hence, it fails to explain the fine structure of the hydrogen spectrum as usual. Sommerfeld theory explain about the shape of orbits only. Again, Bohr's and Sommerfeld theory fails to explain the following facts. The following facts, both the theories are failed to explain. According to Bohr's, we get Balmer series as H alpha, H beta and H gamma are only single line. But when we observe with a high resolving spectrometer, it shows as H alpha line consists 5 lines called fine structure. It is not a single line. H alpha line is not a single line. H beta line is not a single line. H gamma is not a single line. When we observing high resolving spectrometer, each line contains a group of lines, that is fine structure. It could not explain the fine structure of the H alpha, H beta, H gamma by Bohr's and Sommerfeld theory. It could not explain fine structure of H alpha line. So, It is briefly explained about Bohr's theory and drawbacks of Bohr's theory and drawbacks of Sommerfield elliptical orbit theory. Thank you all.